Planetary gear set is also known as an epicyclic gear set. This gear arrangement was first developed by the Greeks in more than 2,000 years ago. At that time, this type of gear set arrangement was initially intended to help predict the movements of planets in the solar system. Hence the name.
This gear set can be said to be the heart of modern engineering, and are used in gearboxes that power everything from basic plant machinery and to cutting-edge electric vehicles. Again, just like you said earlier, the simplest configuration of a central drive and orbiting gears was developed thousands of years ago to model the movements of the planets. A planetary transmission system, or an epicyclic system as it is fondly called. This gear set consists of a centrally pivoted sun gear, a ring gear, and several planet gears which rotate along their individual axes. This gear set's assembly concept explains the term planetary transmission, which is, as the planet gears rotate around the sun gear as in the astronomical sense. It is also the same with our planet. That is, they also rotate around our sun also.
Today, engineers use planetary gears in applications that demand high torque density, operational efficiency, and durability. The advantage of a planetary transmission is determined by load distribution over multiple planet gears. It is thereby possible to transfer high torques to load by utilizing a compact design. So, the transmitted ratio depends on the shaft at which the input or the output is taking place, and the gear that is locked firm. The varying transmission ratios can be explained using different gear set arrangements.
Basically, switching between the three gear sets at a certain time will determine the output speed, the torque density, and the direction of rotations.
Before we will be looking at the direction of rotation, varied speed, and how maximum torque can be achieved practically. It is important that we look at its operational principles. And as such, planetary gearboxes can be configured in four ways, which are fixed ring gear, fixed carrier, fixed sun gear, and direct drive.
In fixed ring gear, the ring gear, which is the outermost gears, is usually held fixed while the other gears is allowed to rotate freely. In a fixed carrier setting, the planet's gears are usually fixed, while the remaining gear are allowed to rotate along their axes. The fixed sun gear, on the other hand, is usually held at a fixed position, while the remaining gears are allowed to rotate freely. The last one is in direct drive settings. In direct drives, all the gears are allowed to rotate freely, without any gears being held at a point.
Now, with all these configurations, 5 laws can be derived with respect to the planet carriers. So basically, we will be looking at how the planet's carriers behave with respect to the other gears. The first one is a neutral configuration. In this configuration, there is no reactionary between the input and output gears. In the second state, the planet carriers is the output. So the resultant motion that will be produced will be less when compared with the input speed. However, in a situation where the planet carriers is the input, the result of this configuration will be overdrive. Now, when the planet carriers is the reactionary, then the output motion will be reversed. That is, the ring gear will be in the reversed order. Finally, when any two members are locked, then the resultant motion will be direct drives.
Now, in order to have more speed at the output, then it involves varying the gear sizes. So in order to have more gear ratio, 2 or more planetary sets are used in combinations. This is called multiple planetary gear sets. Now let's look at these 2 planetary gear sets. in which one is 4:1, and the main planetary gear set is 6:1. Then, the output is 24:1. With this combination, the speed that is gotten at the output is at the lowest. Now when we put the first planetary gear sets in direct drive, and we put the main gear sets in reduction, then the gear ratio will be 1:1 and 6:1. The total reduction is 6:1, which is the second speed. Now, when we put the first gear set in reduction, which is 4:1, and the second gear sets in direct drives, then we will be getting a reduction of 4:1. Now when both sets of gear sets are placed in direct drives, then the output speed will be at a ratio of 1:1.
Now another for the output load to rotate in reverse. The third gear set, in which the ring gear is held stationary, will be removed, making the ring gear to rotate freely, while the sun gear will be made reactionary. This will make the ring gear sets to move in opposite directions.
Another way in which reverse rotation can be achieved is through compound reverse setup. So instead of using the third gear sets just like you just did, the main gear set is used. So it will be set up like this. In the first gear sets, the ring gear is held stationary, while the sun gear is the input. The input of this gear set will be via the planet gear sets. Now from the planet gear of the first gear sets, it will be connected to the input of the main gear set via the sun gear set. So in this setup, the planet gear sets will be made reactionary, while the output of the motion will be extracted via the ring gears. This will further be connected to the last gear sets via the sun gear, and the output will be connected to planet's gears with a fixed ring gear. This setup is known as a compound reverse setup. Compound reverse connection ensures that more torque will be delivered from the gear sets.
Now, when all the ring gears are fixed, and when an input motion is applied, then what we will be having is direct drives in which the output speed is equal to the input speed. Again, in order to even have more speed, the ring of the third gear set will be held stationary. Now when an input motion is applied, the output speed will be a little bit more than the input speed in the ratio of 0.58:1. So basically, when the ring gears are held interchangeably, there will be corresponding changes in the output speed of the gear sets. And that is it for today's series. I hope you have learned something new today. See you at the next one.